Hello friends. My name is B. Ramesh, Assistant Professor in Mechanical Engineering Department, WITS Warangal. Welcome to Witsconnect. And today topic is displacement, position, proximity. Okay, we have discussed earlier class. Those are that is sensors and transducers. Okay, and next one we have discussed the what are the terms are used in transducers. Okay, and the next topic in the second chapter, that is displacement, position, proximity. Okay, displacement means these displacement is the sensors. Okay, displacement means these sensors are concerned with the measurement of the amount by which some object has been moved. Okay, that is nothing but the measurement of the amount by which some object has been moved. Displacement sensors is the use of. What is the use of displacement sensors? When the object is moved. When the object is moved, then we can sensing the element and we can record the total information. Okay, that is measurement. This displacement sensor is placed on the moving object. Then we can measure the total amount of object which can displacement mode. The object moved one place to another place. How much displacement will be moved, that can be measured in displacement sensor. As well as displacement sensor is concerned, the different examples are there. Those examples are we have discussed later. Okay, and the next one, position sensor. Position sensor means these sensors are concerned with the determination of the position of the same object. Okay, determination of the position of the some object in relation to some reference point. Okay, determination of the position of the same object at a reference point. Position is nothing but we can determination one of the object at a particular point, that is reference point. Okay, అంటే మనం ఏం చేస్తాం పొజిషన్ సెన్సార్ లో ఒక రిఫరెన్స్ పాయింట్ దగ్గర ఉన్న దాన్ని మనం డిటర్మైన్ చేస్తే, ఓకే, డిటర్మైన్ చేసేటప్పుడు we can use position sensors. Okay, as well as position sensors also considering the different examples are there. Those examples we can discuss later. As well as proximity is nothing but these sensors are a form of position sensor. These sensors are a form of position sensor as well as used to determine when an object move to within some particular critical distance. Okay, proximity sensor as is same as position sensor, but one is change is there. That change is we can determine when the object, okay, when we can determine when the object move to with some particular, that is some particular critical distance. Some critical distance lo unnappudu maatrame manam we can use the proximity sensor. Okay, then next we move to the example of the displacement sensors. What are the examples are involved in the displacement sensor? That is first one. Those examples are first one, that is potentiometer sensor is there. Okay, potentiometer sensor. This is the rotary potentiometer. Okay, this is the rotary potentiometer, and this rotary potentiometer is consisting different elements. Okay, what is the use of what is the use of rotary potentiometer? It is consist of a resistor element, resistance element. Okay, it is consist of a resistance element with a sliding contact which can be moved, over the length of the element. Okay, it consists of a resistance element which is sliding with the total object and which can be sliding the total length of the object. Okay, then next, such element can be used for linear or rotary displacement. For such element can be used for linear or rotary displacement. The linear or rotary displacement కోసం మనం such resistance element అనేది యూజ్ చేస్తాం, as well as the displacement. Okay, as well as the displacement being converted into potential difference. Okay, in this one the displacement, which is the displacement is the occur that displacement is occur that will be totally converted into potential difference. Okay, that will be converted into potential difference. First of all, potentiometer is consisting as a resistant element. Okay, resistant element which can move over the length of element, that is sliding the total element. Okay, the next one, such element. Okay, such element can be linear or rotary displacement. Such element can be linear or rotary displacement. The displacement being converted into potential difference. Okay, such displacement, that is rotary or linear displacement, or that is the rotary movement, potentiometer rotary conversion is there. The displacement being converted into potential difference. Okay, and in this rotary potentiometer, it will be consist as circular wire wound track. Okay, that is this rotary potentiometer is consist as circular wire wound track. That is wire wound track. పొటెన్షియోమీటర్ ఎలా ఉంటుంది, దీని చుట్టూ సర్క్యులర్ వైర్ తో చుట్టూ ఉంటుందట, అంటే టోటల్ సర్క్యులేషన్ చేసి ఉంటుంది. దాన్ని మనం దట్ ఈస్ సింగిల్ టర్న్ ఆర్ helical turn. Okay, that wire will be single turn or helical turn. This is about the rotary potentiometer. That is the main function is, first of all, potentiometer sensor is, it will consist as resistance element with a sliding contact. It will be consist as resistance element with a sliding contact which can be moved over the length of the element. Okay, the resistant element is consisting as the sliding contact which can move over the length of the element, as well as such can be used linear or rotary displacement. Those displacements are converted into potential difference. As well as rotary potentiometer is consisting as circular wire wound, that will be single turn or helical turn. Okay, then we go next to strain gauge element. Okay, then we go the next one, strain gauge, and the next one is strain gauge element. This is the second one of the displacement sensor. Example of the second example of the displacement sensor. The strain gauge element is consisting as metal wire as well as metal foil, and the metal wire is connected with the connection leads, as well as metal foil is also connected with the connection leads. This is the metal foil. Okay, this is the strain gauge element. This is totally one of the strain gauge element, and this is the strain gauge element. Okay, strain gauge element is consisting of metal wire with the connection leads as well as metal foil with the connection leads. This metal wire connected with the connection leads, as well as strain gauge element is The electrical resistance strain gauge is metal wire as well as metal foil strip. When the when it is subject to strain, its resistance R will be changes. That resistance changes, that is delta R by capital R. That is change in resistance divided by that is actual resistance. That is frictional changes in resistance. Okay, that is frictional resistance in changes, that is proportional to the strain. Okay, that is proportional to the strain. Since strain is the ratio of change in resistance to the original resistance. Okay, then the resistance changes of strain. Then the resistance changes. Strain means change in resistance by original resistance. Then the then the resistance changes. A strain gauge is measurement of the change in length of the element. Okay, length of the element to which the strain gauge is attached. Okay, when the length of the element to which the strain gauge attached. That is mean if strain gauge attached to the one element, this is the element. These are the strain gauge. These strain gauge are attached to the one length of the element, and next we can apply the force on the element. Okay, when the flexible element is when we can apply the force on the element, this flexible element can be bent or deformed as a result of forces. That is, we can apply the force, then the element will be bent or deformed. Okay, bent or deformed. Then the next one, then the electrical resistance. Okay, then the electrical resistance strain gauge mounted on the electrical resistance strain gauge is mounted on this element. Then strain and so we resistance changes which can be monitored. That is, that some resistance or changes in this element because of when the force will applied on the length of the element will be constrained with the strain gauges. If we can apply the force, then next some resistance will be changes. The resistance will be changes. The change in resistance is measured of the displacement. Okay, and the change in resistance can be measured as the displacement or deformation. Displacement or deformation of the flexible element. Okay, some change in resistance will be measured with the displacement or deformation of the flexible element. The next, such arrangements are typically used for linear displacement in order. Those are, we can change 1 to 30 mm in the displacement, 1 to 30 mm in the displacement, and some have non-linearity errors are there. Those non-linearity errors are less or minus 1% in full range. Okay, what is the working of strain gauge? This is the part of the strain gauge element. It will be consisting as metal wire or metal foil, and with those wire is connected with the connection leads. If one strain gauge element we can fix it on the length of element, we can fix it, this strain element will be fixed on the length of element, this length of element. When we can apply the force on the element, that element will be deformed or changes the displacement. Okay, when strain can be developed, the resistance will be changes. Then strain can be developed, the resistance will be changes. The change in resistance, thus measurement of displacement or deformation of the flexible element. Okay, flexible element. Such arrangements, these arrangements are used for the linear displacement. used for the linear displacement. Those linear displacement we can measure 1 to 30 mm, or some non-linearity displacements are there. Those are error for the plus or minus 1 in the full range. This is about the strain gauge element, one of the example of displacement sensor. As well as we can see the next one. The next one, differential transformer. That is the next example of the displacement sensor. Differential transformer is one of the main example, that is LVDT. LVDT. Okay, LVDT means that is linear variable differential transformer. Okay, LVDT means linear variable differential transformer. It will consist of, this is LVDT, it will consist of 3 coils, that is primary coil as well as secondary coil. Okay, it consists as 3 coils, that is consist as symmetrically. Okay, those are consisting as symmetrically along the insulated tube. This is the insulated tube. Okay, these 2 coils are insulated tube. Okay, next one, the central coil is, that is central coil is, this is primary coil. Okay, the central coil is, that is primary coil, and the other 2 are, that is that is secondary coils. Secondary coil 1 as well as secondary coil 2. Those secondary coils are identical. Those secondary coils are identical, which are connected in a primary coil, and secondary coils are connected in a series form. Okay, these are connected in a series form in such a way that outputs opposed to each other. In a such form, output each other. Okay, output oppose the each other in connected in series form. That is primary and secondary coils are connected in series form. Their output is opposes the each, both are opposes to the each other. And next one, in this one, magnetic core is moved through the, in this insulated tube, that is ferrous rod. Okay, in this one, magnetic core is moved through. Magnetic core will be generated. Magnetic core will be moved through the central tube. Magnetic core is moved through the central tube as the result of the displacement being monitored. As the result of the displacement being can be monitored. That is, magnetic core will be moved in the insulated tube. We can result of, then when the magnetic core will be moved in the insulated tube, then we can monitor the total displacement of the tube. Okay, and then displacement is nothing but movement. Okay, that is changing the tube movement. Okay, and the next one, and when there is alternating, in this one, when there is alternating voltage we can supply, that is when there is that is alternating AC voltage supply to the primary coil. When there is supply to the alternating voltage to the primary coil, as well as alternating EMF also induced in secondary coil. Okay, if we can alternate, again alternating voltage supply to the primary coil, this is one primary coil, as well as induced in secondary coil, that is EMF induced in secondary coil. EMF is nothing but electromotive force induced in secondary coils. When we supply the additional voltage to the primary coil, then additional EMF induced in secondary coil. Okay, with the magnetic core in the central form, the amount of magnetic material is there. The amount of magnetic material is placed in this. In each secondary coil is secondary coils also same. When magnetic coils are both are same, then the secondary coils both are the same of the magnetic coils. Then EMF both are same magnetic coils, then the produced electromotive force, the induced electromotive force is same in each other, will produce electromotive force in same each other. Okay. And next one and the same one. Since if we are connected, there is opposite there is outputs are opposed to each other, the result is 0. When secondary coils are same in both, then induced EMF are same, then induced EMFs are same in both are output, then we can get the zero output, but we can when the core is displaced, in a central position, there is a greater amount, that is primary coil is there. When a placed core in a central position is greater than the secondary coil, it is greater than the secondary coil, then the magnetic core will be produced. Then the magnetic core will be produced in one coil. For example, the induced coil is more in primary than the secondary coil. That is more induced EMF force is greater than the first one. That is secondary coil to more than the primary coil, as well as the result that greater EMF force is induced. That result is that greater EMF is induced in one coil than other coil. If we can arrange the more coils on a primary than the secondary one, then the result is induced EMF force is greater than primary coil. Then the difference between the two EMFs, then the difference between the two electromotive force increase the greater displacement. That is output voltage, as the difference between the two secondary voltages are there, that is increased with the greater displacement. Okay, that is increased with the greater displacement. As well as the induced in secondary coil, EMF is induced in secondary coil by changing current in primary coil. That is, if EMF electromotive force induced in secondary coil, when we can change the current in primary coil, when we can change the current, change the current in primary coil. Okay, this is about the LVDT, linear variable differential transformer. If any one coil is greater than the other coil, then induced EMF is greater than those coil. If those coils are same coil, but there is no output will be 0. This is about the LVDT. Thank you.